Well, I'm just about to start to drill the boss plates, pin boss plates. I was going to just show how I pick up the center hole and then show it being drilled out. I'm going to step drill it. I'm not going to try and drill 2 inches in one pass. These are the 3 drills I'm going to use. I've got around a 3/4, I'm not even sure what size, it's around 3/4 of an inch to start with, and then the other one is around, the shiny gold one there is about 1.5 inches, and then the large one at the bottom is a 2-inch, and it has a number 5 Morse taper on it. The spindle in my radial drill is a number 4, so I have a 4 to 5 adapter attached to it. Unfortunately, it makes it so long that I can't use that drill in my quick change chuck. So when I go to drill with a 2-inch, I'll just have to knock the quick change chuck out with a drift and put the 2-inch drill bit in to do the final pass. So it's a little bit slower, but I'm only doing 2 holes, so it's not the end of the world. Now, when you're trying to pick up the center, these chucks have a little bit of slop in them. They're not a completely tight fit, and you can see it wobbles a bit. What I found from using this is that you can actually feel when it's in the center. What I do is I drop that down until it touches the hole, and if it's not in the center when you drop that down, it has a spongy feel to it. Plus, if it's way off, you can see the center move around. And I find that when it is right lined up, you get a nice crisp, hard feeling to it. That's it right there. There's no sponginess. It just hits, stops, and it's nice and crisp. You obviously can't feel that through the camera, but if you were here doing it, you'd know what I mean. So there, we're lined up. So now, and as far as I can tell, this when I raise and lower the arm, I don't lose my position. It follows a key up the column and doesn't swing or move out of the way. This drill has coolant. It didn't have it originally, but I bought a pump and plumbed it in. But I don't have it working right now. I haven't filled it up with coolant since the move, so I'm just going to use cutting oil. Hopefully that'll work. So we're through with the first drill. smooth it. Now this is where I have to remove the quick change chuck so I can mount that 2-inch bit directly into the spindle. So just use a drift key. That made a pretty nice hole. And it warm to the touch, not too bad, considering it was just oil. One thing, if you're gonna do this a lot, drill holes like this using cutting oil instead of coolant, you definitely need to acquire a taste for vaporized cutting oil. It comes off this thing pretty thick and heavy. I got the taste in my mouth right now. Anyways, that's one of the 2 holes, and then I'll move over and just repeat in the other one, and then that'll be done. After I drilled the holes, the 2-inch holes in the pin boss plates, I realized I didn't have a chamfering tool large enough to chamfer the holes, so I used this tool. I think most people have seen that, and it worked okay, but after about 20 years working in the shop, it gave me by far my worst injury I've ever gotten in the shop. While holding the part down with my left hand and pulling that tool around with my right, it slipped out of the hole on the upward stroke, came up and struck my left hand just below my thumb. I'm filming this little bit about 4 months after it happened. There's the scar. But after this, I'll post a picture of what my hand looked like after I got back from the doctor. So it pays to be careful, even with hand tools. Continuing on today with getting the pin boss plates ready before they get welded to the frame. And what I have to do with this setup is put the set screw holes in. They're going to be 1/2 inch 13 threaded holes. And the set screw will go through here, and the long pin that'll pass between these will have dimples in them. And the set screw will hold the pin in so it doesn't get pushed out in either direction. Also keep it from rotating. We don't really want it to rotate in these holes. We want the bucket to rotate around the pin. This is my design, I guess you could say, for how the set screw is going to go. the object that's outlined in red is the set screw itself. We can see the little dimple mark here, which will be in the pin. And then there's a counter bore here, 5/8 diameter counter bore. And the idea of that is we don't want the set screw to be above this surface because it will likely get broken off. Stuff will likely sweep by this surface, whether it's rocks jammed in the bucket, etc. So we want to keep it below the surface so it's protected. But if we just put that in that threaded hole, we threaded it from the surface down, then we'd have the edge of this threaded hole that could get mashed over as well by objects sliding by. And you'd have a hard time getting that set screw out to disassemble this in the future. So by putting the counter bore in, I'm able to use a shorter set screw and get it below the surface, but also get the threads below the surface so they're protected as well. I didn't want any of the female threads exposed, the threads in the hole, however, because I didn't want those getting corroded or plugged up with stuff and then making it hard to back the set screw out. So I've counterbored it, or I'm going to counterbore it below the top of the set screw so that there's no female threads exposed. They're completely filled with male thread, and that'll keep any crap out of those threads. My plan is to use set screws with a nylock insert, which will hopefully hold them from shaking out. And then I want to fill this whole cavity here with never sees so that in the future it's easy to back out. This is going to be outside in the rain and who knows what else, and it'll get pretty messy. So hopefully this setup will protect the set screw, protect the female threads. The nylock insert will keep it from backing out, and the never sees will allow it to be disassembled in the future. So hopefully that'll work. Now I've got this mounted in the vise, sitting at an angle where I've got these holes drawn is where I want the set screws. They don't have to be exactly, they could be placed anywhere along here, it wouldn't really matter. This just happens to be, when it's sitting in my vise, the angle. I can't put them over here because this is going to be welded. If I get them too far over here, then the bucket covers them and you can't get to them. So anywhere and around here is good. And when I go to set up the other way, I'm not worried about getting the holes over here in exactly the same location as the holes over here. It won't matter because these two holes are used for one pin and the other two holes are used for the other pin. And as long as they're put in a straight line here, then all I have to do is dimple the shaft in the same plane and the holes will line up, assuming I get the spacing between the dimples to be the same as the spacing between these holes after they're welded in place. The one issue I ran into was I do want to get these holes centered over this hole pretty close, and to pick that hole up, you can't just pick it up with an edge finder because you can't get the edge finder in here. So I tried putting I have a 2-inch end mill, tried putting that in there, but the hole seems to be just slightly under 2 inch. So what I did was I just turned this pin, it's out of an old piece of shafting that had a keyway. Keyway is not important, it's just left over. And then what I can do is it fits pretty close. I can slide it in, and it's not a perfect fit, so it rocks a little bit, but I can push it against the shoulder, at least hold it square. Then what I can do is I can come in and touch on this side and zero, touch on this side, and then use the half function on my digital readouts, and it'll split the difference between those two, and when I go back to zero I should be right in the center here, and that'll be accurate enough for what I'm doing. Okay, so when I touched on this side, I zeroed this, and now I've touched on this side and that's the reading. And then I just choose half on that axis, and it just divides it by 2. And now when I run the table back, to 0, you can see I'm pretty much halfway there. Earlier I said I was going to counterbore these holes with a 5/8 end mill, and seem to be having no luck getting the end mill to cut through the mill scale or the torch cut surface here. So I'm just going to counterbore it with a 5/8 drill bit. It doesn't matter if the bottom has a bit of a angle to it, it's just a clearance anyways. So we'll set the 0. Okay, and now we'll tap it with a 1/2" 13 spiral point tap. It should push the swarf down through the hole, since the hole is through hole. So this would give a better view of the set screws and how they're counterbored. So they'll sit in there just a bit above where the thread ends, so that the entire female thread is filled. And that should keep any of the thread that has to rotate from being corroded, and therefore should make it easier to get apart. Should. And on that side. Well, I've finally got to the point where I can put the pin boss plates on the weld fixture and then install that on the frame and then have it welded. It's been quite a delay, mostly because I've gotten other work in the shop that was a higher priority, and I finally got back to this. This is what it looks like. These are the pin boss plates, and then the welding fixtures I made. So you can see they're spacing the pin boss plates out the correct distance. I'm using the washers here. They're a step washer with a close fit to the hole in the pin boss plate, and the hole through the washer is a close fit to the threaded rod, and the hole in the welding fixture is also a close fit to the threaded rod. So these are piloted reasonably close to the welding fixtures, so that these are lined up from end to end pretty close. They don't have to be perfect because they'll be bored after welding, but it's always nice to get them as close as you can get. So I was just going to lower them onto the fixture, which I had machined in the last video, and we'll see how it fits. Now what I need to do is just tap this around until I get the frame centered on the pin boss plate. Likely I'll just do that by measuring this gap here, making sure it's the same. And obviously I'll do that at both ends. And then you can see underneath there's that gap, which is caused by this piece of material not being quite long enough, but I think that'll fill in nicely when it is welded up. So it'll be welded across this gap, and it'll be welded on either side of the gusset. Welding fixtures makes it a little tight, but I'll have to see. Maybe once we get it welded in here, then we can take the frames off and finish welding out here. Although that's maybe not the best thing to do, because this was put here to restrain this from pulling during welding, and that's the weld that's going to pull this over if it's going to go. So we'll see. We'll see if they can weld in there the way it is. But that's it. I'll just tack it into place now here, and then I'll take it off to the welder and get it welded up. And then the next step is put it back on the milling machine and bore the 4 holes out at each end using the boring head and my mystery tool drawbar. I got the clamshell bucket frame back from the welder. He welded the pin boss plates on for me, and as I suspected, the frame is moved in slightly, and it's jammed my welding fixture in between the pin boss plates. I've hammered this one a bit with a rubber hammer, got it to move a little bit, but it's kind of stuck. So I'd been worried about this, so my plan was to heat this part up, get the frame to expand. And that's what I wanted to do. Unfortunately, my large propane torch isn't here, so I just have this small one. So I'm going to give it a try and see if it works or not. Well, that handheld propane torch is pretty weak, so I think I'll try something a little more powerful. Now we can actually do a comparison between the new frame. We can see the heavy gussets and the heavy pin boss plate, and that's welded under there, and on both sides of both gussets, you know, it's pretty strong looking. And this is the original. You know, see how thin that is? And the gussets are smaller, and they don't come down here at all. So you can see that was what they were relying on to hold those cantilevered pins that, when they're in use, want to twist this way. Not very strong at all. Not compared to that section.